Hydrogen. Hydrogen stands ninth in abundance among the chemical elements, making up approximately 1% of the Earth's crust. It is the simplest of all the elements known today. In nature, hydrogen exists as gaseous diatomic molecule, that is H2. It has three isotopic forms. Occurrence. It exists widely in combination with other elements. Example, making up 1/9 by mass of water, an important constituent of all acids and alkali. They combine with carbon. Hydrogen is found in natural gas, kerosene, gasoline, and other petroleum products. It is also a constituent of most organic substances, including proteins, carbohydrates, and fats, which are essential components of all living matter. Laboratory preparation. By the action of dilute acids on fairly reactive metals. Hydrogen can be prepared in a laboratory by the action of dilute acid like dilute HCl and sulfuric acid on fairly reactive metals, that is, metals in the middle of the reactivity series, such as magnesium, iron, and tin. Magnesium reacts with hydrochloric acid to give magnesium chloride, and hydrogen gas is liberated. Zinc reacts with sulfuric acid to give zinc sulfate, and hydrogen gas is liberated. Very reactive metals such as sodium, potassium, lithium, calcium, which are very high in the reactivity series, are not used with acid because their reactions will be too violent. Rather, these highly reactive metals produce hydrogen by careful reactions with cold water. Sodium reacts with cold water to give sodium hydroxide, and hydrogen gas is liberated. Calcium reacts with cold water to give calcium hydroxide, and hydrogen gas is liberated. Less reactive metals found lower than hydrogen in the reactivity series cannot displace hydrogen from dilute acids because they are less reactive than hydrogen. Example, copper, silver, gold, mercury. Dilute nitric acid does not produce hydrogen gas with fairly reactive metals except magnesium because this acid is highly oxidizing and will quickly oxidize any hydrogen produced to water. The second method is by the action of hot concentrated alkali solution on zinc, tin, aluminium. The third method is by the action of steam on hot iron or zinc. Iron reacts with steam to give iron oxide, and hydrogen gas is released. Zinc reacts with steam to give zinc oxide, and hydrogen gas is released. The hydrogen gas produced can be collected over water, but if required dry, the gas can be dried by passing it through fused calcium chloride or concentrated sulfuric acid. The dried gas is then collected by upward delivery or downward displacement of air in a gas jar. Remark: in general, there are two methods of collecting dried gas depending on whether the gas is heavier or lighter than air. One, upward delivery or downward displacement of air. This method is used to collect gases which are lighter than air. Example, hydrogen gas, ammonia, etc. 2. Downward delivery or upward displacement of air. This method is used to collect gases which are heavier than air. Example, chlorine, carbon dioxide, sulfur dioxide, bromine, oxygen, etc. Physical properties. Hydrogen is colorless, odorless, and tasteless gas. It is the lightest known substance, hence it is used in filling balloons. It is neutral to moist litmus paper. It has a very low boiling point.